Cross-Site Request Forgery forces a logged-in user to execute unwanted actions on a web application where they are currently authenticated. The browser automatically attaches ambient credentials like cookies to every request directed at the target domain. Traditional session cookies rely on implicit trust. When a script on a malicious site triggers a post request to your application programming interface, the browser sends the session identifier without user consent or knowledge. The SameSite cookie attribute provides a primary defense layer. By setting this attribute to lax or strict, you instruct the browser to restrict cookie transmission during cross-site subrequests. SameSite lax allows cookies on top-level navigations, but blocks them in frames and image loads. While this prevents many simple attacks, it may still leave specific application programming interface routes exposed if they use GET methods for state changes. Never use the GET method for operations that modify data. Anti-forgery protections assume GET requests are safe and idempotent. Violating this principle bypasses standard browser-level protections and creates massive security holes. The Synchronizer Token Pattern requires a unique, secret, and unpredictable value for every user session. The server generates this token and embeds it in the initial application state or a custom header. For every state-changing request, the server compares the token sent by the client against the token stored in the session. If the values do not match or the token is missing, the request is rejected immediately. In a single-page application, you can deliver the forgery protection token through a meta tag or a non-HTTP-only cookie. JavaScript reads this value and appends it to subsequent asynchronous requests as a custom header. The double submit cookie technique works for stateless backends. You set a random value in a cookie and require the client to send the same value in a custom request header. Because cross-site scripts cannot read cookies from your domain, an attacker cannot retrieve the secret value to mirror it in the header. This leverages the same origin policy to verify the request source. Adding custom headers like X requested with or a specific CSRF token header forces the browser to perform a preflight check for cross-origin requests. This prevents the browser from sending the actual request until permissions are verified. Standard browser cross-origin resource sharing rules prevent malicious sites from setting custom headers on simple requests. By requiring a custom header, you ensure the request originated from your own trusted front-end code. Validating the referrer or origin header provides an additional defense layer. Ensure the source domain matches your expected front-end location exactly. Be cautious of privacy settings that may strip these headers in certain browsers. The origin header is more reliable than the referrer header because it cannot be spoofed by client-side scripts. Use it to verify the source of post, put, and delete requests arriving at your load balancer or API gateway. Avoid including anti-forgery tokens in uniform resource locator parameters. Logs and browser history often store these parameters, potentially exposing the secret token to log monitoring tools or third-party analytics scripts. If a subdomain is compromised, it can set cookies for the root domain. This can lead to session fixation or token injection. Use the host-only attribute for cookies to narrow their scope to the specific authorized host.
Single-page applications using JSON web tokens in the authorization header are inherently protected against CSRF because the browser does not automatically attach the authorization header to cross-site requests. If your application accepts both cookies and bearer tokens for authentication, the cookie path remains vulnerable. You must apply standard anti-forgery tokens even if the primary client uses tokens. Regenerate anti-forgery tokens upon login and logout to prevent session fixation. Each new authentication context must establish a fresh, unique token to ensure previous attackers cannot reuse intercepted values. Combine SameSite cookies, custom request headers, and strict origin validation for a robust defense-in-depth strategy. Regularly audit your application programming interface endpoints to ensure no state-changing actions are reachable via GET methods.